Hello students, good morning everyone. So till now we have studied about the how to determine the long-term variations. So we have seen different methods, that is curve fitting and the moving average, and also curve fitting we have done for the growth curves also. How to fit all those growth curves or by the principle of least squares comes under the curve fitting, and we have seen the moving averages method also. So long-term variations we have finished. Next today's class we are going to start about the determination of the seasonal variations in time series. So among the components of time series we have seen about the long-term variations. So today we will start about how to determine the seasonal variations or how to eliminate the seasonal variations. What are the different measures under determining the seasonal variations? So what are seasonal variations which occurs periodically or randomly are called the seasonal variations. So these seasonal variations may be because of the man-made conventions or the natural cause also. So these seasonal variations measures the variations under 1 year, within a year of time. So always for the seasonal variation, the data will be of the less than 1 year. Either it may be quarterly wise, monthly wise, or weekly wise, or the day wise, hour wise. So always the data will be in the form of a less than 1 year format. So this seasonal variations, why we will determine these seasonal variations means, first thing is to know what is this need for the study of seasonal variations is to know or to determine the effect of seasonal variations. So how much effect it is showing on our data. So we determine the effect of that seasonal variation. And the second thing is to eliminate that seasonal variation. So first we will determine what are the seasonal variations, why we are getting those seasonal variations. Second thing is to eliminate or to study about those seasonal variations and eliminate those seasonal variations. So to eliminate the seasonal variations and bring the isolation of elimination, it is helpful to study the effect of cyclic variations. So to study about if you eliminate the seasonal variations, it will help to study about the cyclic variations. So there are different methods of measuring the seasonal variations. Among those, few of them are ratio to trend method, ratio to trend method, second one is ratio to moving averages method, ratio to moving averages method, and next one is linked relatives method. Linked relative method. So these are the three methods which are covered in our syllabus, that is ratio to trend method, ratio to moving averages method, and the linked relatives method. So this ratio to trend method, so we already have the trend method, right? Determining the trend by using the curve fitting or by using the trend line. So it's an extension of the curve fitting, that is about the straight line or the parabola. Whatever the curve is there, first we will fit that curve, and after eliminating the trend variations, we are going to define the seasonal variations. So before going to ratio to trend method, you have to be clear with the straight line, parabola, straight fitting of those curves. The second one is ratio to moving average method. So we have the moving average method, right? So it's an extension of the moving average method. So first we will find the moving average as it is the moving average method. By using those moving averages, we will be finding or determining the seasonal variation. And the third one is linked relatives method. This method is also known as Pearson method. new topic not related to trend. So here in link relative itself we will be finding the trend eliminated values and also the seasonal variations also. So among these three methods today I am going to start about the ratio to moving average method. So this method I said it's an extension of the moving average method only. First we will find the moving averages. For finding the moving average, how we will find the data for the particular period of time? We will be finding the moving averages and placing at the center of those time points until we get the synchronization between the time points and the whatever the moving average value we got. So since it was an easy method, first I will start the ratio to moving average method. So this ratio to moving average method will be having different steps. So if I keep on telling the steps manually, you may not understand it. So first I'll start a problem related to moving average. So after doing the problem, if we do it practically, we can understand the steps also. So first I'll do a problem related to ratio to moving average, and through that problem we will write the different steps involved in the moving average method. So first I'll write the first problem. Now coming to the question, calculate the seasonal indices, that means the seasonal variations are calculated by using seasonal indices. So calculate seasonal indices using the method of ratio to moving average. So if you observe this data, so what you have in your data for different years, for each year the data is divided into 4 quarters. So what are the 4 quarters named with? Q1, Q2, Q3 and Q4. So there are 4 years mentioned in the question, that is 1978, 79, 80 and 81. So corresponding to each year, 4 quarters data is given. So always for measuring the seasonal indices, the data should be of less than 1 year format, right? So here we have quarterly data. So either our data will be quarterly or monthly. So here quarterly data is given. So what is the first step by step we have to do? We have to calculate the moving averages. So by calculating moving averages, we didn't have this format, right? We used to have the data like this, that is particular years, then will be there was a year-wise data. So quarterly we didn't do, right? How to do this means? So first coming to the first step is we have to calculate moving averages. So here the data is divided quarterly. So there are 4 quarters. So since calculate 4-year moving average, 4-year centered moving average values. Centered moving average values. So data is quarterly. So you will calculate the 4-year moving averages. If the data is monthly, so there will be 12 months, right? So if the data is monthly, you have to calculate the 12 years moving average. So remember, first step you have to check whether the data is quarterly or monthly. So here the data is quarterly, so we will be calculating the 4-year moving average. If the data is monthly, you will be calculating 12 years moving average. So how to calculate the moving averages? We know the procedure for calculating the moving average, right? So first we have to write all the years. So each year there are 4 quarters. First write down years. So in this years you have quarters also. And then we have to calculate the 4 years moving average. So how will you write the years? First write down the 1978. So corresponding to 1978, how many quarters you have? 4 quarters. So write down those quarters, that is Q1, Q2, Q3, Q4. Similarly, next is 1979. So corresponding to 1979, write down the 4 quarters, that is Q1, Q2, Q3, Q4. Next is 1980. So corresponding to 1980, there are 4 quarters. Write down Q1, Q2, Q3, Q4. And the last one is 1981. So corresponding to 1981 also 4 quarters. Write down Q1, Q2, Q3, Q4 values. So you will write the data like this. So after writing the quarters, next you have to write the values. So how will you write the values? First 1978. For all the 1978 we have written 1, 2, 3, 4. Quarter 1, quarter 2, quarter 3 and quarter 4. So write all those values. So here write down those values. So what are the values? First is 10, 27, 21, 40. So 1978 finished. Next come to 1979. You have the values 11, 35, 29. Next 57. Next 1980 values are 14, 51, 33, 74. Next 1981 values 19, 57, 43, and the last value is 78. Now we have got the same format for calculating the moving averages. Now what we have to calculate, since it is a quarterly data, we have to calculate 4 years moving average. First, suppose if it is given monthly data, you will have total 12 values, right? It's 1978 and 1979, 2 years monthly are given. So under 1978 you will get 12 values and under 1979 you will get 12 values. So total 24 values you have to write like that. If it is 3 years, you will be writing total 36 values. So first you have to write your data like this. Then in the next step, you have to calculate the 4-year moving average. 4-year moving average. So this is a even number, right? The period of the moving average is 4. 4 is even, means you will not get the synchronization between the time points and the moving averages. You will get value in between 2 values. So first you calculate the moving average of first 4 values. What are the first 4 values? 10 plus 27 plus 21 plus 40 divided by 4. So the average you will be getting as 24.5. So what is the middle one for this? Between Q2 and Q3. So you will be writing the first value here. That is, what is the answer? 24.5. 24.5. Similarly, next 4 values. 27 plus 21 plus 40 plus 11 divided by 4, you will get 24.75 in between Q3 and Q4. 24.75. Next value, I will leave the second one, start from third one. 21 plus 40 plus 11 plus 35 divided by 4, you will be getting the answer as 26.75. 26.75. Next is 40 plus 11 plus 35 plus 29 divided by 4, you will be getting 28.75. 28.75. And the next is 11 plus 35 plus 29 plus 57 divided by 4, you will be getting as 33. Next is 35 plus 29 plus 57 plus 14 divided by 4, you will get 33.75. Next is 29 plus 57 plus 14 plus 51, you will be getting as 37.75. Next is 57 plus 14 plus 51 plus 33 divided by 4, you will be getting 38.75. Next is 14 plus 51 plus 33 plus 74 divided plus 43 plus 78 divided by 4, you will be getting 49.25. So these are the last 4 values. Next you don't have the next 4 values, you will be getting only 3 values. So you stop here. Next what we have to do, there is no synchronization between time point. So we will calculate 4 years centered moving averages. So how we calculate the average of the first 2 numbers, we will be placing in the middle. That we have here one value and here one value. Between these two, the middle value is Q3. So you will be writing the average of 24.5 plus 24.75 divided by 2. You will be getting 24.625. So where do you place this one? Exactly at Q3. So that is 24.625. So at Q1 and Q2 of 1978, you will be not getting any moving average value. Next you find out the average for next 2 values. So next 2 values are 24.75 plus 26.75 divided by 2. You will get 25.75. Next 26.75, 28.75 divided by 2. You will get 27.75. You have to write in between these 2 values. Whatever the answer you got, write in between those 2 values. Next 28.75 divided plus 33 divided by 2, you will get 30.87. Next is 33 plus 33.75 divided by 2 is 33.37. Next 33.75 plus 37.75, you will be getting as 35.75. Next 37.75 plus 38.75, you will be getting 38.25. Next 38.75 plus 43 divided by 2, you will be getting 40.87. Next 43 plus 44.25 divided by 2, it is 43.625. Next is 44.25 plus 45.75, you will be getting as 45. In between those 2 values, 45 is 45.75 plus 48.25 divided by 2, you will be getting 47. Next last 48.25 divided by 49.25, you will be getting 48.75. So we got the last value in between those 2 values, that is at Q2. So for the Q2 of 1981, we got the last value. So what are the first 2 values? Q1 and Q2 for 1978 and Q3 and Q4 for the 1981. We don't get the any moving averages values. Next step is, what we have to do is, we have to express the original data into the center moving averages by considering the first and last 2 values remains empty. So whatever the values we got here, we have to express this. Here we got the at Q3, right? Whatever the answers we got here, that we will be writing in that format. Whatever the answers we got, that answers we will be writing here. So how do you write this? Second step. What is the second step? Step 2 is express original data in terms of moving 4-year moving average, that is the centered moving averages value. So that is the first step. If you want to write here, this is step 1. Then next step 2 is we have to write the moving averages. Here we have quarters, here we have years. How many years we have? 1978, 1979, 1980, and last 1981, Q1, Q2, Q3, and Q4 values. Now, these values, whatever the moving averages we got, that values we have to write. 1978, Q1 and Q2 values, we did not get any values. So keep it as empty. So next step, Q3 we got 24.625. The next value is 25.75. Similarly, write down all the next values. That is 27.75. Next 30.87. Next is 33.37. And next value is 35.75. Next value is 38.25. And the next value is 40.87. And the next value 43.625. You can write all up to 2 digits only. You can write 43.62. Next is 45. And the next value is 47. And the last value is 48.75. And we did not get the moving averages for last 2 time points. So this is the data in terms of the moving averages. So this is the second step. So whether it is a monthly data or quarterly data, the same step. If it is monthly data, you will write all the 12 values. Quarterly data, I am writing only these values. So here, the 4 years we are calculating, the first 2 values will be empty. Suppose if you are calculating for the monthly data. So whenever you are calculating for the monthly data, the first 6 values and the last 6 values will be empty. For quarterly data, remember first 2 values and last 2 values. 4 years moving average, 4 values will be missing. First 2 and last 2. For the 12 years moving average, first 6 values and the last 6 values will be missing. That is total 12 values will be missing. Now we will move on to the third step now. So step 3 is you need to express this moving averages as a percentage of original data. So express the original data as a percentage of moving average. Express original data as a percentage of moving averages. So whatever the center moving averages we have, that you have to express in terms of percentages. So what is the formula is ratio to moving average is equal to ratio to moving average is equals to the formula we are going to use is, since we are expressing the original data as a percentage of moving average. So original value divided by moving average value, original value divided by moving average value into 100. Since we are finding the percentage of original as a percentage of moving average. So original by moving average into 100. So how will you find this one means? So draw one more box. 1979, 1980, 1981. Quarters are Q1, Q2, Q3 and last Q4. So now how you will find the percentages means what is the original data we have. So check out in the question whatever the values given in the question that are considered as the original data, and whatever the moving average we got, that second step 2 table is the moving average value. So for the first and second we are not going to get any values. So coming to the third one, what is the original value of the third value? That is Q3 is 21, right? So 21 divided by what is the moving average value? 24.625 into 100. So make sure the original means the question value divided by whatever the moving average we got into 100. So if you do, so this is Q3, 21 divided by 24.625 into 100. If you solve this one, you will get 21 divided by 24.625 into 100. You will be getting 85.29. 85.29. Similarly, here also, what is the original value? 40 divided by moving average value is 25.75 into 100. What is the answer we are going to get here? We are going to get it as 155.33. 155.33. So this is the second step. So these percentages represent the seasonal and irregular variations if we use the multiplicative order. Now complete this box. So similarly complete the remaining box also. You will be getting the ratio to moving average values as 39.63, 113.37, 86.90, 159.33, 36.60, 124.78, 75.65, 164.44, 40.42, 116.92, and the last two values will be as it is. So this is the third step. Next we will move on to the fourth step. Step 4 is we have to find the totals and averages for the given quarters. So for the given data, it is quarterly data. For each quarter, we will be finding the totals and average. If it is monthly data, for each month you will be calculating the total and averages for each quarter. So first find out the totals and then find the averages. So first find the totals. Whatever the totals you got, by using those total you find the averages. Here you have 3 values. So total divided by 3 you will get 38.87. Second here also you have 3 values. So 355 divided by 3 you will get 118.33. Next here also you have 3 values. 247.84 divided by 3 we will get 82.61. And similarly the next also we have 3 values. So 479.21 divided by 3 we will get the 159. So these averages are nothing but these averages are called the seasonal indices. Whatever the averages are there, these are called the seasonal indices. So these seasonal indices, we have to make some adjustments in the seasonal indices. In the fifth step, we are going to calculate the adjusted seasonal indices. Adjusted seasonal indices. So how to find this adjusted seasonal indices means the formula for the adjusted seasonal indices is adjusted SI. Seasonal indices we will be writing with SI. 0.69. And the last one is seasonal indices of Q4 equals to average of Q4 into K. So seasonal indices of Q4 is equals to, the answer is 159.88. So if you add all the 4 seasonal indices, whatever we got, that should be approximately equals to 400. So this is the procedure for finding the seasonal indices for using the ratio to moving average method. In the next class, we will again discuss about the method clearly. Today we have seen the problem, so make sure you understand the problem first. We will discuss the method